This is 1.4, D as in dog, fourth video. We're going to start down in the middle of page 31. I'm just going to give you those three Pythagorean identities there. They did the proof at the top there, but I'm not going to go over that. But those three identities were derived from the Pythagorean theorem, x squared plus y squared equals c squared, or r squared, because r is the radius, or r is the hypotenuse of that triangle on the xy axis. So this is the r. And I talked a little bit about the unit circle, where r is 1. The radius of the unit circle is 1. They call it a unit because the radius is 1. It's 1 unit. So you can use the formulas. You can derive the formulas, the Pythagorean identities. Sine squared theta plus cosine squared theta equals 1. Tangent squared theta plus 1 equals secant squared theta, etc. And I'm not going to have you learn why that works. It's just being able to use those in your problems. One of the other identities is called a quotient identity, because what we do is if we take the sine of theta and we put it over the cosine of theta, that equals, let's see, what is the sine of theta? It's y over r. The cosine of theta, let's see, cosine is going to be x over r. Now if we just ignore this now and we invert and multiply, it's r over x, my r's cancel, and I get y over x. Y over x is tangent. So the tangent of theta equals sine of theta over cosine of theta. So that's one of your quotient identities. And not only is sine of theta over cosine of theta tangent, but if we flip those and write it as cosine of theta over sine of theta, we get the cotangent of theta. So those are another couple identities that are good to have. So let's go ahead and look at example number 5. And they tell us to find the sine. We're looking for the sine. If, gosh, that brings me up to an old song, doesn't it? Tangent, all right, so we're looking for the tangent of theta and the sine of theta. What information are they giving us? They're giving us the cosine of theta equals negative square root of 3 over 4. And they're telling us theta is in quadrant number 2. So I'm going to draw my picture here, and that always helps me. I've got an angle here. Let's just put an angle in there, make a triangle. And this is my theta. And my cosine of theta is negative 3 over 4. That's all they give me. But I know cosine is x over r. So I know that my top number is my x, and my bottom number is my r. Now, I need to find the length of this based on that information. So I can take square root of 3 squared plus y squared, which is what this is, equals 4 squared. So I get 3 plus y squared equals 16, y squared equals 13, y equals the square root of 13. Alright, so that gives me my y value. So what I have right now is, let's get rid of all of this stuff here now that I figured out what my y value is. So what I have is I've got x is equal to negative square root of 3. Y is equal to square root of 13. And r equals 4. Well, what are they asking me to find? They're asking me to find the sine and the tangent. Well, I know the sine of theta equals y over r. Well, I've got a y here, square root of 13, and my r is 4. So there's my sine of theta. They also asked me to find the tangent of theta. Tangent of theta is y over x. And that is, my y value is square root of 13, my x value is negative square root of 3. And then all I have to do is multiply top and bottom by the square root of 3 to get rid of that square root of 3 symbol. Square root of 13 times the square root of 3 is the square root of 39, and that's going to be over 3, and it's going to be negative. So there is my tangent of theta. There is my sine of theta, given just some basic information there. Last example, last part of section 1.4, they're asking us to find in example 6 the sine of theta and the cosine of theta if we know that the tangent of theta is 4/3 and theta, the angle, is in quadrant 3. So we do this, quadrant 3, we just draw an angle, doesn't matter where it goes, but that's our triangle. Tangent of theta is 4/3. Well, we know that tangent of theta is y over x. So we know this is my y and this is my x. What do I also know? I know that in the third quadrant my x and y are both negative, and I don't know what my r is. I know it's positive, but we're going to use Pythagorean to find out what my r is. So negative 3 squared plus negative 4 squared equals r squared. So 9 plus 16 equals r squared. Keep going and find out r is 5. So I know y is negative 4, x is negative 3, and r is 5. So given that bit of information, I can very easily find out what my sine of theta is. Because sine of theta, I know, is y over r, right? So y is negative 4, r is 5, and I just found the sine of theta. And they also want me to find, let's see, what else? Cosine of theta. Well, I know cosine of theta is x over r, and my x is negative 3, my r is, what did I say my r is? 5. And therefore I have my cosine of theta. The book does it a lot different than I do it. So, you know, you can kind of figure it out the way you want, but that is one method of doing it there. Let's see, that's it for section 1.4.